in Fluent. So that is, we are going to create a new variable for the pressure coefficient and for the skin friction coefficient. So in order to do that, I'll go to user define and custom. Here there is field function custom. So here I can create custom variables. Here you can see that there is a calculator, or we can also select our flow variables. Yep. Okay. Yep.
Did we have class today at 8? Yes. Where?
You need to click this.
Usually 3:05. Which one? You can put that. I didn't either, so why? I didn't go. I didn't go into anything. Nothing. No, but you can go manage anything. Like study, anything. Nothing. So that's a problem. I'm really afraid of. I took the facing. I took the first exam. I'm gonna retake it again. You retake the both? Yeah. I'm okay with my score, but I want to take again in case like it's higher. Yeah, okay, it's better. I forgot to create to pass my first project in advanced smart phenomena and payment. He's not replying to me. Yeah, he never replied to the email. He never. Oh, so I should just tell him in the class. Yes, better. Don't do. Okay. Yeah, because ignore the emails. Don't forget to work. Something I will post it in my Facebook. Oh, you edited it? Yes, exactly. I was not online. It was on. I like the photos. You are photogenic and erotic. Thank you so much. I can never give you 10 euros, but nobody ever. This will do the best. Yes. So cute. Really enjoy their collection. Exactly. So pretty. Yeah. The places. I would love to buy a camera so I could, because I love taking photos. But even with the phone, it's awesome. It is, but I think it's better if it's real camera. This where's our guy. Super nice guy. What was the activity here? What was the activity here? Aurora hunting. And then afterwards we ate food. Marshmallow.
Okay, so as I was mentioning, that we can create these custom variables that are basically flow variables that are calculated for the wall domains and for the boundary conditions. So the first one that we can calculate is the CP. So the pressure coefficient, which is here I have a square brackets. Then I select the pressure, static pressure. Then I select minus P infinite. So P infinite here we need to write that value. There is 99,000. This is in pascals. Then we are using
And
SI
also,
units.
could you
Yeah.
just repeat the steps again after custom?
For the custom variable, so
Yes.
then, yeah, in this user-defined custom, we have this custom field function calculator, where we basically have here a calculator if you need to make some maths
Mhm.
calculations, and then here we have field functions. That is basically all the flow variables are stored
Okay.
in the solution, and you can access them from there to create new variables for the flow that are computed for the whole domain.
Okay.
So this calculator is using SI units, so our pressure will be in Pascal.
Mhm.
So then here to set the P infinite in pascals, which is 99,846. Close the brackets and over 1/2, so 0.5 times rho infinite, which is 1.16 times u infinite, so 44.2 at the power of 2, and close the round bracket. So by doing that, then we can rename the function. We can call this CP coefficient. Define. And we can actually plot it. So we can create a new XY plot. On the X direction, we can select on a Y-axis function. You can see that here now we have an additional value that we can select these custom field functions, where you can find all your custom field functions. So in this case, the CP coefficient, which I can plot over the bottom wall. So across the stem, and I can plot it there. So you should get something like that. But as I was mentioning in the beginning, this is not going to 0. So we were told in the description of the case that if we want to compare these results with the results that are on the website, we should have a CP equal to 0 at x over h equal 40. Right now, at x over h equal 40, we are getting okay, that's interesting because when I was running this at home, I got a different value. Now it's quite different. So when I was running it before, I got this 162. Now it's 143 around. We can check what values that by writing the file. So I'll write this in a CP coefficient.xy file. So you can check on this text file for x over h equal 40. So that means that let's say this one is x over h equal 40, which for us this is x equal to 0.4 meters, so 40 centimeters. So let's go to find the x equal to this is not ordered. Maybe when I write the file I can order points so that the point will be ordered for the x coordinate. So I can rewrite this, overwrite this file. Let's check. Yes. And we get here a value around 0.141 around. So we can create a new custom field function. So always using the calculator, where we are selecting our CP coefficient and we subtract the value we calculated in here. So that for me that was 0.141.
No, can you open?
So I'm going to call this CP coefficient adjusted. And define. So I'll close this. Now I can go back to my plot. And I can plot this CP coefficient adjusted, which is now going to 0 for x equal to 0.4 meters. So now this is directly comparable with the value, or with the values shown in the website. Okay, then the next thing we need to plot or to calculate is the skin friction coefficient, CF. It is given here. Now, you should be careful that this CF is calculated based on the wall shear stress, but not the magnitude of it, but the x value. So the x component of the wall shear stress. That's because the magnitude is always positive. So even if we have negative values here, then the magnitude will result in a positive value, which is wrong. So we need to consider the x component, which will be negative in this region of flow separation.
Okay, you have here, we are going to check the correctness distribution, which is correct, 1, 2, 3. And then you can use what? Instead of number, you can you can extract the infinite value at center also. You can do that by one file.
I'm using that, I don't know. More
Save this file. You can go find value
0.1, right?
0.045.
forward.
How do you choose
Ah,
for
yes.
the statement?
The center.
Ah, it's only
Yes.
Yeah, we get the value at center.
Yes, you need to.
141.
Yeah, that's enough.
Same here.
The center.
On that point, it's center of channels.
Order points just looking you only based on your x-axis values. So when you write the file, then you set it to no, it's correct. Order point is just once you write the file. Yeah. And it's a text. And object point means that it's ordering in a ascending order. Yeah. So you can find the center. Yeah, yeah. I was using 44.2 enough, yeah. And you can do the same then for pressure and then see.
Okay.
So in the same plot you can rectify this.
This one is for,
This one is the question.
okay.
Okay, so then we can calculate the skin friction coefficient. So I'll go again in user defined custom, and here I can write a custom function for the wall skin friction coefficient, CF. So as I was mentioning, here we need to select the, so in field function we go to wall fluxes. In wall fluxes here you can find the wall shear stress, but we need the X wall shear stress, that is the X component. So we select this one, and we divide it by round bracket and 0.5 times rho infinite, so 1.16 times 44.2 u infinite at the power of 2. And we can create this